there's product rule, chain rule, and quotient rule. Which you have to know how to do. To take the derivatives of all the stuff you need to take the derivative of. So we're starting with product. That's probably the simplest. It's a little weird because you don't really need product unless you're using it with chain. So today you're going to be like, well, I don't need to use this rule, but we're just going to practice it anyways. Because if you get to the part where you need it with chain rule, you have to know how to do product rule. It'll make more sense why you learn this rule when we get further on. So this is supposed to be the same rule. I'm just trying to describe it two different ways. Some people think about it like an f and a g, and then it would be g times f prime plus f times g prime. Some think about it as like the first chunk times the second chunk. If you're thinking that way, it's the second chunk times the derivative of the first chunk plus the first chunk times the derivative of the second chunk. So it's the same. I'm saying the same thing there, just two different ways. Okay. Are we good? Does everybody have this written down? So let's look at just a regular example. Let's say I gave you x to the third times x to the fourth. Well, if I combine those, that's really x to the what? 7. And what is the derivative of x to the 7? 7x to the 6th, right? So I want to show you why product rule is necessary before I just start teaching you what it is. It is tempting to look at this and be like, well, so this is wrong. What I'm about to write down doesn't work, but I'm just showing you why. It's tempting to look at this and take the derivative of the first thing and multiply it by the derivative of the second thing. So what's the derivative of x to the third? 3x squared. What's the derivative of x to the fourth? 4x to the third, and we get 12x to the fifth. So the point is, did that method work? It did not, because we're supposed to get 7x to the sixth. We know that. So if you just take the derivative of the first and the derivative of the second, you multiply them together, it's not going to work. Again, product rule is not necessary for this problem, but if I were doing it, I would think about that as my first chunk, that is my second chunk. You do the second one as is, times the derivative of the first one, plus the first one as is, times the derivative of the second. So the second one is x to the fourth. That's my second chunk. Times the derivative of the first chunk. That's 3x squared. So this is what I'm calling like D1, derivative of the first piece. So 2d1 plus, then you flip it, plus 1d2. So you rewrite the first chunk, leave it as it is, and then we multiply that by the derivative of the second chunk. So what's the derivative of the second chunk? 4x cubed. Now let's simplify. So that's going to be 3x to the 6th. That's going to be 4x to the 6th. What do I get? 7x to the 6th. Now, would I ever do that problem that way? No. But if I gave you this problem, I would never expect you to use product rule. I would say combine them, take the derivative. But there's going to be times when you can't combine them. Don't really get to yet, so this is a little bit weird because I'm giving you a rule you don't actually need yet. But we have to learn it in order to do the next step. So first of all, does it make sense that you can't just take the derivative of each and multiply them together? Like I showed you that didn't work, right? So this rule does work. Questions on anything yet? Alright, so let's do one where you're a little more likely to use it, I guess. I don't know. You still probably wouldn't, but let's say 3x plus 5 times x squared minus 6. Well, if I gave you that problem for real, I would not expect you to use product rule. So I'm going to do it like that way first, and then we'll do product rule, make sure we match it. What I want you to do here would be just FOIL. Figure out what you get, and then take the derivative of each part. So if I FOILed this, what's 3x times x squared? 3x cubed. Outside would be negative 18x. Inside would be 5x squared. And the last would be negative 30. This is not product rule, this is just me showing you like how you'd probably do it. And the derivative of that would be 9x squared minus 18 plus 10x, the negative 30 would drop out. So if I'm telling you this product rule works, we better get the same answer, right? It is more of a pain. It's not the way I would go about doing it, but you gotta know. So again, I would think about my first chunk and my second chunk. Product rule says you leave the second chunk as it is, then you multiply by the derivative of the first chunk. And then you just flip flop. So I left the second one times the derivative of the first one. Then I'm going to leave the first one, multiply by the derivative of the second. So this is 2 d1, 1 d2. And then go ahead and simplify that. Make sure you get what you're supposed to. Yeah.
You put negative 5 and you put 3x minus 5 instead of x.
Is that what you're talking about?
Yep.
Is that it? Okay. Yeah, thank you. This would be 3x squared minus 18, that's probably where that 18 comes from, plus 6x squared plus 10x. So if I combine those, I got my 9x squared, I got my negative 18, and I got my plus 10x. So like if you were on the AP test or a chapter test and I gave you this problem, I don't care which way you do it. I just care that you get to the answer. But again, we need to practice the product rule for things down the road. Questions on this anywhere? So let me give you, try this one and just use product rule. I don't want you don't care if you do the other method. So just do product rule and find the derivative. So the second thing, 2x plus 5 times the derivative of the first thing, which would be 8x, plus the first thing, times the derivative of the second thing, which would be 2. And then you're just doing the algebra from there. And some of the algebra on that sheet's a little more. Some of it is, like you got binomials times binomials, you have to FOIL. But how would you end up with that? Questions on it? Where'd you get this from? I got something different. Did I screw something up?
Yeah.
Oh, minus 2. It is a 2. It's just ugly. How many got that? Yeah.
I have to show you something I wrote down. Okay, so we had this sheet from Miss Manny last year, like a calculus cheat sheet, and it has all these like product rules and stuff on it. So it wrote it differently like this. So is this G? Is it just in a different order?
Yeah, I'll show you what.
Okay.
I'll show you why. I'd show you that order too. So if I give you y equals f times g, product rule, I teach it as g times f prime plus f times g prime. Is it the same if we do f times g prime plus g times f prime? Those are the exact same thing, right? I just flip-flopped them. The reason I teach it in the order I do is because when we do quotient rule, f divided by g, it's going to be g times f prime minus f times g prime. And now all of a sudden order matters because I got subtraction sign. So that makes order matter. So I'm trying to keep these in the same order as each other. Where that other way, like this way isn't wrong, but then you got to remember to switch the order.
That's a different order. I have even a different order on here. I have
For quotient rule you do?
no, for product, not for quotient. I have f prime times g plus f times g prime.
That's what I have.
Oh, I see where.
You just like flipped,
The f prime
you just like
times
exchanged those. Yeah.
It looked more confusing on my paper. Saying it out loud helped.
Okay. So, but this happens every year. Like, people are like, wait, if I'm just adding them up, does the order make a difference? And the answer is no, it doesn't. But I'm teaching it to you in this order so that quotient rule becomes easier. So just keep that in mind, I guess. Let's say... Whoa. Nice, thank you. Try that. Let me see that.
Yeah. When we started doing your notes and stuff, we got through like the first page, but then we passed that. She taught G really too. She had like this little line thing, which I don't remember. It's different from what's on the page. You wrote down the same thing that's on the page. I think so. Maybe not. I wasn't really paying attention to the changing part. I know.
How can you say it's not different?
No, what you wrote down on the board when you were explaining the product rule.
What's that for something? What's that for the chain rule?
You said they were different. Never mind.
So this is one where you actually need to use product rule. Like, you can't get around it. And the ones we did before, like with the algebra, you can kind of work your way there without the product rule. This one you have no choice. So remember, you cannot just say, I'm going to take the derivative of f, the derivative of g, and multiply them together. That doesn't work. That's what I was trying to show you with like that x to the 7th one that we did. So you have to use the actual product rule, which is the second thing times the derivative of the first thing, plus the first thing times the derivative of the second thing. And in all those cases, x is 2, right? So I can just go 2, 2, 2, 2. And then you're just plugging in numbers. So what is g of 2? Negative 1. What is f prime of 2? 0. What is f of 2? 3. You guys see where I'm getting the numbers from? Nobody's saying anything. We're good? Okay. And then g prime of 2 would be 4. So this part is just 0. How many got to 12 as your answer? Nice. I didn't even show you how to do that yet. Questions on it? Yeah, I like those because it's not like tons of algebra to get to. Yeah.
Well, I've never seen product rule quick written out with a table and given x is equal to 2, so that was a fun little challenge to get into.
Nice. So I gave you a worksheet on product rule. How many are on there? You don't have to count them. There's numbers next to each.
15.
So if I were you, I would do like the odds. If you're getting the odds right, I would probably do the odds. If you get them all right, I probably wouldn't bother doing the evens. If you get the odds, do the odds, and you miss a couple, then the evens are there for just more practice. But if I came around tomorrow and checked it, like to hold you accountable for it, and I saw the odds done, that would be enough for me. Fair enough. If you need more practice, do it. You should do it. But I'm not going to force you to. I want you to, yeah. So the answer key shows you the first step, and then the answer. I want the answer, so I want that all simplified out. I want you to do that. The first step is just there so you can kind of check that your steps were on the right path. Did they do the same order we just did, or did they flip-flop it? They flip-flop it, yeah. That's like the traditional way of teaching, I guess. I think it makes more sense to the other way, but watch out.
For some reason, I have it in my head, it's like f prime g plus g prime. It's the same thing.
That's fine.
I know. I think that's the one I don't know what I meant.
It works. What I do?
I can't remember exactly what she said, so I'm misquoting the story.
No, that's fine. I'm not. But you get used to one way, so then when you see something right the other way, it scrambles my brain for a second. But I have to
That's fine.
recalibrate.
I had 3 different ways we were
Right.
doing.
It's a little happened with the chain rule story, but that's different. Different issue, I think. You taught chain rule once. I've never taught chain rule. Oh, well, product rule.
She's
also been a while, so.
Now change them on the board.
When?
When you were
Where?
product rule.
He didn't write it. Quotient.
Oh.
Second after my right.
Oh, the one that wrote on the bottom there?
Every time I said chain rule, I was thinking the quotient.
Every time I said I enjoyed having you in class, I meant the opposite.
You asked for it. You said you wanted someone to ask for it.
No wonder. I was like, what are you talking about?
You need a nap. I need you really need a nap.
You guys be working quiet, please.
Wait, how's that 24? Did I miss the next